and you can share your presentation. That's it. Thank you.
Thank you, Marco. So I think you can see the presentation. Yeah?
Yes, I can see.
Okay, great. So hello, everyone. Good morning, everyone. So now, a few months ago, Tom Huber, who is one of my geology students at Imperial, asked me if it was possible to come to his old college, so in Henley, your college, and talk about my experience as a geologist. This was well before lockdown, and I was supposed to come physically to the college and see all, but not virtually, definitely. And then everyone knows what happened. So I would definitely have preferred to see you in real, but with Marco, we decided to still go ahead, even with the COVID-19 situation, and here we are today. So as Marco said, I will mainly speak about my experience with geology and show you plenty of photos, of pictures of the different field trips, mainly that I had done as a student first and then as a teacher. So here you can see a picture that I took last year during one of the second year field trips at Imperial in Scotland. So the title of this talk is Geology is the Best Choice of My Life. It sounds a bit like a drama movie title, but I hope that at the end of my talk, you will be convinced that I choose the correct title. So let me just start by introducing myself. So Marco has already told you my name is Valentin Laurent. I am French. You have probably already guessed that from my horrible British accent. And I'm working at Imperial College. So I am a geologist, which is specialized in, you can read it at the bottom of the slide, in structural geology, metamorphic petrology, geochronology, and Mediterranean geodynamics. Plenty of different words that you probably don't really understand, but it's not so complicated. So structural geology, it means really the study of the rocks in the field, the deformation of the rocks, as you can see in the background. Here the rocks are deformed. And the idea is really to study this deformation to better understand Earth's processes and processes that guided plate tectonics, for example. So it's really, a structural geologist is really the caricature that you can have of a geologist going into the field with a hammer and a compass and looking into the rocks. Metamorphic petrology is really, metamorphic rocks are a specific sort of rocks, and they are really interesting to study the processes such as the formation of mountain chains or subduction zones. And I'm really specified mostly in these rocks. Geochronology, it means that I did during my PhD a lot of dating. So I tried to date the rocks. Just not only to understand the processes that guided typically plate tectonics, but also to constrain the rates at which these processes happen. And finally, Mediterranean geodynamics, because I mainly studied the Mediterranean area, and I will speak about that. So what am I doing actually? I'm still asking myself why I choose this picture, because, okay, you have my name in big, we don't really care about it, you know, my name is Valentin, but I am, as it's written there, a senior teaching fellow in pedagogic transformation. Again, a very complicated title, we'll come back on it later. And I started working at Imperial College London not so long ago, it was 2 years ago now, 2.5 years ago. So the first part, senior teaching fellow, is quite easy to understand. I'm teaching quite a lot, yeah. So I'm mainly teaching courses on my specialty, so in structural geology. So typically I'm teaching a course about maps and structures, how to understand geological maps. I'm teaching about metamorphic petrology also, And to the first year, I'm teaching a course called Geomaterials, which is all about how to recognize minerals and rocks that compose the Earth. And I'm also doing a lot of field trip, yeah, leading some field trip. And then there is the second part of my title in pedagogic transformation. So this is just, I am also working, not only teaching, but also working, doing some research on how we can improve, if you want, the way on which that we are teaching, how to improve our teaching. So probably the best is just to give you an example. This is known as the Edgar-Dale's cone of experience. I don't really know if you have already seen this sort of diagram or if you have already heard about passive learning versus active learning. But if you want, something that we try to do actually is really to pass from a passive learning where the students are only hearing a lecturer, for example, during 3 hours, to active learning where students are doing things. And like that, they will better learn. Okay, you can see here that it's people generally remember, so more or less the learning activities. So when you are only hearing someone, like typically like me today, you will be able to remember only something like 20, 30%, 50% really maximum of what I will say. But if you are doing something, and I will give you an example just after, you will remember more than 90% of what you are doing. So it's really an active learning, and you will, if you want, learn better. So just let me give you an example. I told you I am teaching a course to the first year students that is called Geomaterials, and which is really all about recognizing minerals and rocks. So at Imperial College, our time slots are 3 hours. So during 3 hours, and probably during 3 hours, I will give a lecture of 1 hour approximately, something like that. And during this 1 hour, I will try to learn to the students how to recognize a specific rock or specific minerals, if you want. Yeah, we'll give them the clues, what to look at, and this sort of thing. And then during 2 hours, I will give them hand samples, really real samples. And during these 2 hours, they will work on them. They will try to apply the knowledge I give them in the lecture. And they will themselves do something by recognizing the minerals, trying to recognize the minerals and the rocks. And like this, they will better learn. Yeah, so really it's working, and it's just a single example. I am working on plenty of different things, but it's part of my job. If you have come to university 20 years ago, probably your parents, if they went to university, they were probably more passive learning than active learning, because it was a professor quite a long time ago now, it was not yesterday, but professor just speaking to the students during 3 hours. Yeah, and like this, you can only remember, you see, what you can hear and just what you can see, something like 25% of what was taught. So now it speaks a bit more on what has been my career path since joining ICL. And here you have a picture of me at your place in 2008 when I was in college. So at that time, yeah, it was quite a long time ago. At that time,
Valentin, I don't think we are seeing the image you are talking about. We're still on the first picture.
Oh, you are still on the first.
It might be that it's not on the presentation mode.
Okay, so that's not an issue.
Yeah, now we can see it. Yeah.
Okay, so let's do. Don't know why the presentation mode is not working.
Do you have 2 screens where you're working at?
Yeah, I'm working on 2 screens.
It might be that's the issue. Maybe you sharing one of the screens but not the other. Okay. But now we're seeing the presentation. Yeah. Okay,
great. Thanks. So this was what I'm doing actually. So okay, I will go quickly over it. You see the senior teaching fellow in pedagogic transformation, and this was the experience cone, just showing between passive learning here and active learning. Yeah, so I will just repeat probably quickly. We have time for that. So here on the left side, you have what people generally remember. Okay, so when they see or hear something.
Sorry, Valentin, we're still looking at the picture of you in ICL. They might
it's really weird. Okay, so no, it's not working. It's
yeah,
okay,
now it's working, yeah.
Okay, so let's do it like that. Yeah, this.
Sorry.
Okay, great.
Now it's working, yeah.
So here is, it will be okay. That's why I said I would have definitely preferred to be really physically in Henley College.
Yes, it's always better.
So here is a kind of experience, okay? So here on the left side, you have what people generally remember, and here is when you can only see a lecture. For example, you remember something like 30% of what was said. Well, once you are doing something, so more an active learning, okay, you are remembering 90% of what was talked. It was what I was saying. It's working in there? Okay, yes, so this is a picture of me at your place in 2008. Quite a long time ago, but not so much, when I was in college. And at that time, I wanted to be a primary school teacher. I was not really sure about what I wanted to do. Mostly to be a primary school teacher, also physical educational teacher. But in France, because I did my study in France, of course, to become a primary school teacher, you needed to do a master. Okay, it doesn't really matter which master exactly, but you needed to do a master. And so I decided to do a master in geology, a bit by hazard, I think, if I can say that. I liked geology at that time in France. Yeah, I should say that in France, every high school students are doing geology. It's a bit different than in England, but you are doing geography, and you have some similarities between geography and geology, definitely. And so I liked, at college, I liked geology, and so I said, okay, why not? Why not trying to do a master in geology? And then I become a primary school teacher. But as you can guess, I really, really love geology, and I then just continue with it. So I did my license in Grenoble University. It's where I'm born and where I live. So I didn't went really far from my parents' home at that time. And so it's a three years, okay, the license in Grenoble. Here are some pictures of, I told you I will show you plenty of pictures of field trips, mainly because it's my best memories, if you want. It's really, I always love field work. So here was a first year field trip in the Auvergne Volcanoes National Park, some recent volcanoes that we have in France. So we went to the volcanoes, learning about igneous rocks. We did also a bit of mapping of some volcanoes. So we had within a group here, so this was my groups. We had volcanoes that we had to map. So to map the volcano is just looking to the different rocks and reporting into a geological map. During my second year, we did a field trips into the Alps. So we've seen some glaciers, as you can see there, close to Chamonix in the Alps. We did also a bit of mapping. You can see me after a really heavy rain taking some measurements of limestones here in this case. So yeah, I spent really great time during my lessons during field trips. Then I moved to Orléans, which is just south of Paris, to do my master and then my PhD thesis. So when I moved from Grenoble to Orléans to do my master, I really, really, really had no idea that I will be doing a PhD. It appears that then I had this opportunity, but for me doing a PhD was a bit like something impossible at that time when I was studying in Grenoble, but definitely not. It's definitely doable And if you like geology, if you, and this is true for any scientific discipline, but doing a PhD is something possible, really. Don't have this sort of barrier. So I moved to Orléans, and here again, we had plenty of field trips. So in France, also, I just say that in France, the master is 2 years. In England, it's only 1 year, but in France, it was 2 years. So during my first year of master, so year 4, we did again a field trip into the Alps, but this one was at a higher level. So we did a transect across the Alps from France to Italy. And the idea was to understand the structure of the Alps, if you want, and then be able to reconstruct the history of the Alps, typically how this mountain chain was formed. So it was, again, really, really exciting and really nice, looking to very, very well and famous rocks. And then during my year 5, so second year of masters, we had a wonderful field trip in Greece. So we visited the area around the Corinth Rift. So this is a picture of the Corinth Rift. And then we visited and looked to the geology of some Cycladic islands. You can see some pictures there. I can give you some names if you are familiar with Cycladic islands, Syros, Tinos, Mykonos, and also on Santorini. You probably have heard about Santorini before. It's quite famous for tourism. And it's also in geology very famous for the volcano. Santorini is an old volcano, and we did a bit of volcanology there. And so, as I told you, I also did my PhD thesis at Orléans. And at the beginning, I told you that I was specialized in the Mediterranean geology. And it's mainly because the field target of my PhD thesis, so I had a subject, but the field target, the rocks I studied, was rocks from the Cycladic archipelago. Because I told you I was mainly interested in metamorphic rocks, the study of metamorphic rocks, and within the Cycladic archipelago, you have world-famous metamorphic rocks that we call eclogites and blue sheets that form in subduction zones. So by studying these rocks, I was able to better understand the processes that happened in subduction zones, when you have two plate tectonics that converge towards each other and one is subducted below the other. So that was mainly what I did in my PhD thesis. And it was really a wonderful adventure, this PhD thesis, if you want. I just put 4 pictures there. So my PhD was 3 years, as you can see, 3 to 4 years. It was 3 years and a half. But I would have been able to show you 200 pictures, I think. It was really, really, but then you would have been bored. But it was a really, really nice experience. During a PhD thesis, you also have the opportunity to participate to conference. So it could be small conference that will be quite close to your university. So in this case, somewhere in UK, where you only have 20 to 30, 40 persons, or it could be very big international conference, such as the AGU that I did in San Francisco in 2016, so during my PhD. And you have here a picture of one of the hall, one of the room, if you want, where researchers can just make their poster. So you can see some poster there and speak about their research. So it's a really, really huge conference. I think it was something like 15,000 geologists. So it's really big ones. And I mean, going to conference is also really nice because you are traveling. I like traveling. You are traveling, you are meeting some of your colleagues, and within conference, you can also most of the time do a bit of field trip. And so it's what we did also in San Francisco. And then after my PhD in Orléans, I directly joined London and was appointed as a senior teaching fellow to Imperial College London. Then I don't know what will the future reserve to me. Will I stay in London, or if I'm looking to my trip from Grenoble to Orléans and finally London, I am expecting myself to probably have my next position in Scotland or Iceland and probably finish my career in Greenland. I don't really know. It's a bit weird because I like hot weather, but yeah, that's something like that. Okay. So I mainly spoke about my career path, but now let's have very few words about geology. It's really quite quickly. Okay, it's only this slide about what is geology. This talk is not aimed to be a lecture about geology, but more about my experience. So geology, the word geology means literally the study of the earth. Yeah, geo is the earth and logy means the study of. So geology, by definition, is the study of the composition, the structure, and the history and evolution of the earth. Yeah, mainly what I am specialized at. But in reality, geology is really more, is wider than that. Yeah, and it combines a lot of various and different disciplines, such as geophysics. I put some of them there. Planetary sciences, so you can see that it's not only the Earth. Now, with the development of new technologies, we are able to study the composition, the structure, even the history and evolution of other planetary sciences, of other planetary planets, sorry. But also climatology, the study of the atmosphere, volcanology, geodynamic, mineralogy, paleontology, and so many more. So really, if you are interested in geology, don't think that geology is only what I showed you today, which is more about my specialty in structural geology. Geology is really, really wide, yeah? So now I'd like to do like a small exercise with you, because in geology, something I know that you are not really used, for most of you at least, used to geology, and the time is quite different in geology than in our life, if you want. So here you can see 9 different events. Okay, the Cedar Gorge Formation, an earthquake in Japan, a human life, volcanic eruption, opening of the oceans, a football match, a football game, meteoric impact, a mountain chain formation, and the 100 Years' War between France and England. That's why I choose this one. So this exercise, or game, let's call it a game, it's more something like a game, is twofold. The first thing, I will ask you to try to order these events from the quicker one to the ones that takes the longer one, if you want, the ones that takes the longer time. So if I give you a clue, a mountain chain formation will be longer to form than the duration of a football match. Yeah, just something like that. So from the shorter events to the longest one. And then the second thing, this is the easy part, and the most difficult part, you can try to estimate how much time every event is taking approximately. Okay, of course, for all these events, even for a football match, it's approximately how much it's taking. So I think we can do that during something like 5 minutes, 4 or 5 minutes, and I will grab myself a coffee during this time. Yeah, that's okay, Marco?
Yeah, that's fine. I think it's good. Yes. Okay. So you'll have now 5 minutes to think about this, and maybe we can unmute and have a bit of a discussion. If you don't want to talk, you can always use the chat. So 5 minutes to see if we can do this exercise. I'll try to do it myself as well.
Yeah, and after 5 minutes, I will give the answers.
Okay, so guys, if you want to unmute yourselves and try to figure out this as a group activity, you can.
Yeah,
so try to think about what you think it takes the most time, the longer time, and the one that takes the least time. Order them, and then try to do an estimation for each of them. And I have a student here who got dropped down and needs to join again. Okay, I'm going to invite Luke. Luke, are you here now?
Yeah.
Good. So did you hear what Valentin said about this activity or not?
No. Sorry.
No. Okay. Valentin, the screen turned white for some reason, and we can't see the image. So you have 9 images in there, and you need to order them in terms of the events you think it take longer, and from the longest event to the short event. And then Valentin wants you to try and think about estimation of how long each of these events take.
You can see the images now?
Yes, I can.
Okay.
Yeah, thank you. Okay, so let's see if we have some people here who can help. Marley, are you there, Marley?
Yeah.
So what would be your guess for the longest event here?
I'm not sure. Maybe like the mountain formation.
Okay, and what sort of estimation do you have for the mountain formation?
Oh God, I have no clue.
You don't need to give an exact number, but do you think we're talking about like seconds, millions, thousands, billions?
Like millions?
Millions? Okay, do you want to throw a number?
Let's go 2 million.
2 million? Okay. Let me see another person. Loti, are you there, Loti?
Yeah.
What would be your second one?
I'd say maybe the opening of the oceans.
Okay, and do you want to throw a number and scale, time scale?
I'd say it's a bit less than the other one, maybe 1.5 million.
Okay, so we go from 2 to 1.5 million. Okay, good. Nico, are you there, Nico?
Yeah.
What about next one in the line, in your opinion?
The Cheddar Gorge Formation.
Okay, and what sort of time scale would you put for this one?
A million years.
A million years, okay, so we go 2 to 1.5, 1 million year. Let's see another person on the list. Dak, what will be next on the line for you?
I'd put the 100 Years' War then.
100 Years' War, okay, so you go from a gorge formation to 100 Years' War. How long do you think that will that last?
100 years, I'm guessing.
I think it's a good bet. Finn?
Probably the human life.
Human life? How long would you give to a human life on average?
Like 85 years.
85. I hope I live more than 85 years. But okay, 85, we can say 85 years. Let's see, who do we have more? I'm just selecting random people here. Ollie Martin, you there?
Yeah.
What about next in the line for, in your opinion?
I'm not sure. Probably. Probably the one in the bottom left. I can't really see what it says though because it's covered by my toolbar thing.
Meteoric impact?
Yeah.
Okay. How long do you think it will take?
I'm not really sure.
Seconds, minutes, hours, weeks, years?
Oh, I actually know because I've just sort of understood what it means. Probably a football match.
Football match. Okay, so we all know the football match is around 80 minutes, more or less. Okay, so depending on extra time or not. Scarlett, what about next after football match? You don't have many choices now. Earthquake, volcanic eruption, or meteoric impact?
I have no idea.
That's fine. There's no right or wrong. You'll probably be surprised with some of the timescales we're talking about in here.
Volcanic eruption.
Okay. How long did you think a volcanic eruption could last?
I don't know. Days.
Days. Okay. So we go now from. So you probably put volcanic eruption before football match, in your opinion, right?
Yeah.
Yeah. Okay. Good. Maybe we can have one last person. Shauna, are you there?
Yeah.
So what did you put next? Earthquake or meteoric impact?
Earthquake.
How long do you think an earthquake lasts for?
Hours.
Hours. Okay. Good. Valentin, are you happy with that or?
Yeah, okay, so let's have a look. I did something, it should have been like an estimation. It was really nice. So you did very well. So you are practically right on everything. So the first one is meteoric impact. Okay, it just takes a few tenths of seconds. You have the meteorite that impacts the Earth. It's really the quick one. Then it's an earthquake. I take an earthquake in Japan, and typically earthquake in average happen during few seconds to maximum a minute, but it's most of the time few seconds. Yeah, you have the impression if you have experienced an earthquake before, you could have the experience. It's really longer than that, but it only takes few seconds. Then it's a football game. And not a match de foot is in French. I forgot to do the translation. So it's, as you said, approximately 90 minutes. Then volcanic eruptions. So volcanic eruptions, it's not really precise. It can be few days to few months, usually in average. Yeah, of course, it depends of the volcanoes and of the cases. Then human life, which is something like 80 years in average. 80 years, 85 years. Yeah, I don't really know about the number, but yeah, it's that. Then the 100 Years' War, and it's not 100 years, I like this example, but it's 116 years, that long, like the 100 Years' War. Finally, and you did practically everything correct, perhaps between these two. So then it's the Cheddar Formation, and it took not a million years. It's quicker than that. It's more something about few thousand years. Yeah, it's really due to erosion. So you had a river that passed through the Cheddar Gorge, the Cheddar Formation, and from the gorge. So it takes few thousand years. But at the scale of geology, few thousand years is really practically instantaneous. Yes, that's why I told you that we don't have the same conception of time in geology, because in normal life, few thousand years is something really long. Yeah. Nothing happens few thousand years, or only things really old. While in geology, few thousand years is practically instantaneous, definitely. When we are thinking about the formation of mountain chain, typically in average, they take few tenths of million years. So your estimation was quite correct. We are speaking about million years. Yeah. And finally, the opening of the oceans take few 100 million years. Again, it depends on the ocean, but if you take like the Atlantic or some of the most larger oceans on Earth, it takes few 100 million years. So well done, everyone. Okay, so we are close to 40 minutes. So now I just would like to say a few words about about studying geology at Imperial College. Yeah, it will be quite quick. So what we propose is either a 3-year course, so doing a BSc, or doing an MSI, which is a 4-year courses. Yeah, and we have mainly 3 degree schemes, 3 different degree schemes, which are Earth and Planetary Science, Geology, and Geophysics. So I told you that you have various disciplines in geology, and typically what happens is that during the first year, you are studying more or less all the students there. Either they choose Earth and Planetary Science, Geology, or Geophysics. They have the same core modules. Okay, the core modules are in common. And then the more you advance toward year 2, year 3, and year 4, if you decide to do an MSI, you will specialize in Earth and planetary science, in geology or in geophysics. Yeah, and within the MSI degree schemes, you have the opportunity to do a year abroad. So we have some students that go to the United States, to the US, or can go to Switzerland, and we have partnerships with different universities all over the world. And here is just, again, something that I really liked when I arrived to Imperial College, is that at Imperial College, we really put a high importance on field work and on doing field trip. And it's something really important, I think, personally. So here, if you choose to go to study geology and you want to go to Imperial College, during your year one, you will go in southern Spain, close to Almeria. And this is for all degree schemes. As I told you, in year one, every student have the same core modules, if you want. So it's to give a taste to everyone about field work. But then, of course, if I came back here, the geology students will do more field work than the geophysics one, for example. Then during the year two, the geologists, and as an option for the Earth and planetary science students, go to the Spanish Pyrenees and to Scotland, both of them. Okay, there are 2 field trips in year 2. So Tom Hubbard, my students, my geology student that I spoke about, he is actually in year 2, and he should have been to the Pyrenees and Scotland this year. Of course, it was not possible due to lockdown on the current situation, but we hope to go there in September. So in the Pyrenees, students are more or less looking to the formation of the mountain chains of the Pyrenees and looking a lot to sedimentary rocks. While in Scotland, we are looking to metamorphic rocks, the one I told about, and students are doing a lot of mapping. So something like 8 to 9 days of mapping in this. This is part of the mapping area. Okay, so it involves walking along this area and map the rocks and do a geological map. In year 2, then the geology students, and only the geology students, this one, they do a big independent geology mapping project, which is something that happened around during 5 weeks approximately. So they choose a field target in Europe. To give you an idea, this year, they all choose a field target in Greece. That was quite funny because we have different localities all over Europe, in France, in Spain, in Italy, in Sardinia, a few different localities. But this year, all our students decided to go either on some Cycladic islands or in Crete. Yeah, it's what we had: Santorini, Syros, Samos, other Cycladic islands. And so during 5 weeks, they have a particular field area that they map. So you can see one of the students there with her geological map. And so, yeah, it's really a big project. I didn't have in France, this doesn't exist. And I really would have loved to do that when I was a student, but it doesn't exist in France. And during the second year, still, the geophysics students are going to Cyprus. And there, they do a lot of geophysical measurement and yeah, this sort of thing. I never went, so I can't tell you exactly in detail. But there are a big field trips also for geophysics students. And it's an option also for the Earth and planetary science one. In year 3, the geology and the Earth planetary science, if they want, go to Sardinia. That would be a bit quicker. But you see, there are plenty of different field work. And this one is really interesting. So this year, with the lockdown, we did a virtual Sardinia field trip. We can't do this field trip in September because we have some year 3 students that graduate. So we had to do a virtual Sardinia field trip, and it was really nice. We created an application which looks like typically like a video game where you were able to visit the outcrops, look to some pictures. You have some 3D model of the outcrops. It was quite fun. It really looked like a video game, definitely. And so during this field trip, at the end of this field trip, the student had the opportunity to do a research project and to write an article on one of the outcrops that they liked during the field trip. So they write an article, and to give you an idea, we have created this field. This fieldwork has been created something like 7 to 8 years ago, and since that we had 2 students that has published their work in a scientific journal paper. So the work that they did during this field trip, which is amazingly great. And then the year 4 students, geology and an option again for Earth and Planetary Science, they are going to the Apennines, Elba and Elba Islands in Italy, and they look to the formation and they look to active tectonics. So processes that are still active actually. As you can see, as you can guess in this picture, fieldwork is really great, but it's true that it's also stressful and very tiring. So here they are making a joke, but it is true that it's quite tiring, but I definitely love that. Okay, so I more or less finished to my presentation. I came back on my first slide here, and I hope you are now convinced that geology was definitely the best choice of my life. To be honest with you, this morning when my wife has seen my presentation and she said, "Oh, am I not your best choice in your life?" So I was quite laughing, but geology has allowed me to meet my wife. So definitely geology is the best choice of my life. And now if you have any questions about anything, it could be about geology, about Imperial College, or just more about university, please feel free to ask. And anyway, sorry, Marco, before I give you I stopped sharing my screen. Anyway, at the beginning, I put my email address also, and if you have a question later on and you would like to ask me, feel free to send me an email. Yeah, it's quite easy and practical. Thank you very much.
Thank you so much, Valentin. I can put your email on the chat if you don't mind, and then if the students obviously have future questions, they can contact you directly. Now, guys, you have an opportunity to ask any individual questions about anything you want, Imperial College, Valentin's career path, geology, anything. So you can use the chat, or you just unmute yourselves and ask the questions. Any questions are welcome. Take this as an opportunity for you, especially for the ones who are not entirely sure what you guys want to do after A-levels. These are probably the best sessions to ask questions. So don't be shy. Just share whatever. There's no stupid question here. So anyone have any questions or any thoughts you want to share about the presentation? Anyone who's interested in doing geology after this presentation? Let me see the chat. No one have written anything.
I can probably say something because
yes,
during admissions we are speaking a lot with high school students, and one of the questions that came back quite frequently is about how it is at university, if you want. What does it look like a typical day at university? So at least in our university, at Imperial College London, we have 3 hours time slots. Yeah, as I told you. So you will have 1 lecture in the morning and 1 in the afternoon. Yeah, definitely. And as I told you, it's now forbidden at Imperial to do 3 hours lectures by just speaking during 3 hours. Yeah, because as I told you at the beginning, students are only able to remember 25% of what the professor would say, the lecturers would say in this case. So what happens is most of the time you will have 1 hour lecture or 2 hours lectures. It depends of the lecturers. But myself, I'm doing mostly 1 hour lecture. Year after year, I'm trying to reduce this time of lecture and increase the time of practicals. And after this 1 to 2 hours lecture, you have 1 to 2 hours practicals. And you are doing something. I gave you the examples of having some samples in your hand to recognize the minerals and the rocks. But also you will be able to use microscope to study thin sections, or practicals could be just like handwriting exercise, and you have some GTAs. So GTAs are PhD students and postdocs that are there to help the lecturer to answer the questions during the lectures, because the class size is approximately around 80 students in year one. This year in year one, we had 80 students. So we usually have 7 to 8 postdocs and PhD to help during practicals answering the question.
I think another question that some of the students ask sometimes is what sort of careers they can do with the degree in geology.
Yeah, so that's a really good one. I would say that you have two different paths. The first one is the academic one, and the second one is the going to industry. Yeah. So I took the academic path. So let's start with this one. So then at the end of your master, you can decide at the end of your BSc first, and if you are doing a master on MSI, you can decide to do a PhD study, and this academic career path, if you want, guide you then toward becoming a lecturer or researcher or something like that. At any time, it could be just after your PhD. We had a lot of PhD students who do that. You can move towards the industry path. Yeah, it's not because you are doing a PhD that you can't work into the industry. And the second one, if you are doing a BSc or an MSc, is more to go towards the industry. And then I told you that geology is really wide. Okay, it implies a lot. It combines a lot of various disciplines. So you can work in really a very wide range of industries, really wide range of industries. Could be environmental industry, could be within the ore and resources, the petroleum industry, really plenty of different things.
Thank you. I think, Ruth, did you raise your hand? You want to ask something?
Yes, I did. I'm, for the benefit of the kids, I'm Tom's mum and the governor of this department, so it's my fault Valentin is here. When I applied to Imperial College, we were concerned as a family about the cost of the fieldworks, because most students, a degree is quite frighteningly expensive. But at Imperial College, the cost of most fieldworks is completely covered, isn't it, Valentin?
I think you sound cut a bit, Ruth.
Oh, did it cut out?
Yes.
My terrible internet.
Now we're hearing you a little bit better.
It was that the cost of the fieldworks was quite daunting for us as a family, on top of the cost of a degree. But in most universities, and certainly at Imperial College, the cost of all but, I believe, the independent mapping project are covered by the university as part of your £9,250. Is that not right, Valentin?
Yeah, it's completely right. As you said, we cannot cover the cost of the mapping project, and it costs in average, it's hard to say something, but in average, between around £1,000, I would say. It can be slightly less, can be slightly more, depending on where you are, what will be your accommodation. Oh, sorry, this is my phone. But you can also have some financial help if you struggle to pay this mapping project. But then everything is included. All the field trips, yeah, the cost is included into the fees.
Any other question, guys? Anything you want to know about Imperial Geology before we finish off, or not? No? Okay, so I think that's it. Thank you so much, Valentin. That was really good, very helpful. I will post your email to students, and then obviously if they have any questions, they will contact you. And we'll probably do this again next year for the new students as well.
Yeah, that would be really nice, and hopefully it will be a real presentation.
Yes, I hope so. Thank you so much.
Okay, you're welcome.
Thank you.
Thanks, everyone.
Thank you, guys. If you guys want to stay, I'm going to stay here for 5 minutes. I'll see the environmental science students later on in the day. I'll stay here 5 minutes, probably Valentine as well, in case you want to ask any questions. If not, have a good week, and I'll see you next week for the geography one. Bye.
Thank you.
Thank you.
Thank you.
Thank
you.
Thank you.
Thanks.
Thanks.
I'm going to stop recording.